Voice check. The sound is clear. Just confirm me. Yeah. Good morning, India. Welcome to Global Gate Academy. So, this is Satish Kumar, Faculty of Instrumentation. How are you all? So, I am starting on YouTube for the especially on Global Gate Academy. We are starting the instrumentation interview concepts. Okay. So, nowadays what is happening, instrumentation students, with respect to instrumentation family I want to talk. So, these instrumentation students, when they go for the interviews, they are facing literally a difficult problem. They are talking about, they are getting the questions about the latest technologies that are used in the instrumentation industries. In our so-called our engineering colleges, our curriculum may be containing in the last units the advanced things, but the students are not focusing majorly on the last units or the advanced subjects. Most of all the advanced subjects will come in the 4th year. So, because of that, what happens when the student goes to the interview, definitely the way of answering the questions is in void. For the student, these questions are appearing like a new field. We could have studied in the B.Tech second year or third year, he would have studied sensors and transducers, but when he goes to the industry, he is getting a questions on HART protocol and Modbus protocol, what is IoT. Okay. So, these are the ways of questions he is getting, my dear. Yeah, there is a glitch. So, keeping this in mind, especially for the students who are preparing for the industrial interviews, definitely they should do some homework, they should do some research work about the advanced things that are happening in the instrumentation industry. Coming to the gate is one criteria and coming to the interview is a different criteria. There are many experiences from my student circle, those who secured good ranks in the gate instrumentation, around 1 to 50 also or 50 to 100 also. Sometimes they are unable to get an interview like companies like IOCL, BPCL, HPCL, NTPC, ONGC, Navaratna companies. And not only that, when you go for the private industries like automation industries like oil companies, Gulf countries, Petronet, petrochemical companies, pharma companies, what the industry is expecting, whether the student is this interview person who came for the job, whether he is already having some experience, basic experience, at least some theoretical, but nobody. That is a problem with instrumentation students. Experience matters. See, in the college we will be working on the 8085 microprocessor. Yes or not? In our college we are studying on the 8085 microprocessor or 8086 microprocessor or 8051 microcontroller. Most of all the engineering colleges, they will focus only on the basic programs like arithmetic, addition, subtraction. But when it goes to the industry level, the industry is expecting the starting from the interrupts, because for a microprocessor interrupt is the major criteria, my dear. So, they will ask you certain program which is related to interrupt handling mechanism. One second. Sorry, there was some audio disturbance. So, with respect to industries, when they come, the same microprocessor which they studied in our B.Tech, but when it comes to the industry, they are asking the serial data communication, they are asking the RS-232 and how two microprocessors between the communication is possible. Such type of questions are very actually practical questions. The students are facing a lot of issues. There is a lot of gap between the study of our instrumentation subjects in our BTech curriculum, and when it comes to the industry level, there is a lot of difference, there is a lot of gap is there. Here today onwards, every day I used to discuss at least half an hour or 40 minutes on the advanced topics of instrumentation on this Global Gate Academy channel, so that the students who are preparing for the interviews, they can use this particular content for the benefit of their interview. Whenever you are going for an interview, especially my dear students, what are the instrumentation interview concepts? When it goes to the interviews of instrumentation, interview preparation concepts, what they are going to ask. Dear aspirants, remember, majorly they will ask industrial concepts only. Majorly they will ask the concepts related to industrial concepts only. Industrial concepts only. So, what are these industrial concepts, my dear? Depending upon the automation, every industry is trying to go for automation. They want to reduce the manual intervention. They want to reduce the manual intervention. Yes or not? They want to reduce the manual intervention. They want to reduce the manual intervention, and they want to make automation wherever it is possible, wherever it is possible. So, with respect to automation, tools, they are having some idea. There are certain tools or softwares, like when it comes to the our instrumentation, majority of the tools or softwares are the hardware. So, questions will be majorly on these particular points, on hardware and what are the tools and the software. For example, basically they will have, if for instrumentation students, majorly they will ask the fundamentals of PLCs, and sometimes they will ask DCS, distributed control systems, and they will ask advanced microcontrollers, like LPC2148 microcontroller, PIC microcontroller. This is what industry using, not 8051. Good morning, Anindya Bose. So, PLC is programmable logical controller, distributed control system. Please share this session to maximum of your circle. Advanced microcontrollers like LPC2148 microcontroller and PIC microcontrollers, and some basic idea of development of embedded systems. They will ask some fundamental questions on development of embedded systems, embedded systems, and they will ask the programming like LabVIEW, and they will also ask the basic understanding of C, embedded C, and nowadays they are also asking some basic programming of Python. Now, tell me, how far you know all these things, basic things? Do you have any idea? And most importantly, advanced topics like AI topics, artificial intelligence, AI related. Today, the AI came into the market, artificial intelligence. Under this artificial intelligence, we are having Internet of Things, machine learning, ML, and big data analytics. Data science. So, these all are essential, my dear, because the computer science is entering into every domain of instrumentation. The artificial intelligence and the Internet of Things is the basic of our automation. People who wants to make the machines to rethink themselves and they want to develop some automation. So, how far you have some basic idea of all these things, my dear? When you go for industrial interviews, you should have the fundamentals of these preparation concepts, but how far you are having, and some protocols. They are having some protocols also, advanced protocols, DCS related protocols, communication protocols, most important. What is Wi-Fi? What is the HTTP? What is the HART protocol? What is the TCP/IP protocol? What is LoRaWAN? What is the Wi-Fi? What is the Bluetooth? What is Zigbee? Basic ideas. Thank you, Rohit. So, these particular things, how far you please inquire, question yourself. Do you have this idea at least? How many of you instrumentation students are watching this session? Do you have this idea, my dear? PLCs, how many of you are using in the college? Different number of PLCs are there, like Allen Bradley PLCs, Siemens PLCs, GE Phonak PLCs. So, the PLC commands, how many of you know? How many of you know advanced microcontroller programming? Not 8051, advanced microcontroller programming like RISC, ARM process, ARM. Even 8051 also, at least 8051 is a basic. But in this also, do you have the programming language of embedded C? Or assembly language programming is okay, but do you have the perfection in the embedded C? Very good. Embedded C. Programs like interrupts, not simple programs like programs on interrupts, programs on serial data communication, programs like related to RTOS. Of course, RTOS means you have to go for these advanced microcontrollers. So, these basic ideas, my dear, basic ideas, real time operating system, some basic idea they are expecting, my dear, from the industry, their expectations of industry. At least they will have some expectation on you, na? Expectation of industry on you. As or not, Rohit, what I am saying is correct or not? See, when you are going for a bench company, when you are going for a Tata Motors company, or when you are going for a Ashok Leyland company, or when you are going for a Eicher Motors company, or when you go for a Maruti Suzuki company, or you are going for some advanced technological companies, they will expect the basic things, because they won't ask you the fundamental question, what is sensor, what is transducer, what is Wheatstone bridge. They are expecting some basic programming knowledge. So, please re-enquire yourself, are you comfortable in this zone or not? If instrumentation student or instrumentation faculty, jo kuch bhi ho, whoever they are, they have to go on, keep on updating myself, keep on updating yourself. Now, right now I am updating myself to IoT technology. Right now I am updating myself to a hardware called LPC2148 microcontroller. These are my updates. Update. You can't avoid it. Just like the KGF knowledge. Famous dialogue, right, in KGF, violence, violence. Everybody is using the tagline. So, we have to update ourselves. If you are not updated, you are out of date. If you are not updated, you are out of date, my dear Ananja Bose, my dear Rohit Soni. Instrumentation students are diamonds. GATE is just a option for instrumentation students. Please remember this point. GATE is an option, but there are many options when you come out of the industry for instrumentation. Automation tools are there. So, that depends upon your choice, whether you want to go for higher education or you want to enter into top 10 PSU companies. Based on that, your GATE. And PSU companies expect something from you, a good rank and a good score, and also a good knowledge on these tools. At least some basic things, yeah. I think most of all the engineering colleges in this present curriculum, definitely they will have these subjects in their BTech curriculum, yes or not? They are definitely in the third year or fourth year, they will be having the PLCs, advanced microcontrollers, embedded systems, LabVIEW, C language in the first year, in the third year embedded C, as an elective Python, and as an elective these topics will be there. Maybe. Yes or not? We have to search Abhishek Pandey, search, research. Satish, Abhishek, search, research, get, practice. That is the only mantra. That is the only mantra, my dear. We have to update ourselves. In the community, there are today, internet is there now. In my days, when I completed my B.Tech, and if I want to go for the PLC training, I used to go to Bangalore. From my village, I have to go to Bangalore to learn the PLC programming on Siemens. But today, thanks to internet, we are having some open softwares, free open softwares, and nowadays the tutorials are happening from the various PLC companies. You take any PLC companies, they are having good exposure, and they are giving some package. They are sending the PLC tools, hardware to the home, and you can install that software in the computer and you can practice in a budget of 5,000 to 15,000. Also courses are available. Yes or not, Anand Jabos? I think you are a faculty, you know this very well. I have worked on PLC, there are no such full information is available. So, Rohit Soni, you have worked means what? You have to go for some industrial environment. For example, in Hyderabad, we are having some centers. For example, in CCM, in Hyderabad, we are having, in Balanagar, one center is there, automation center, MSME center is there. They are having certain machines which are operated by the PLC. We have to go there and we have to learn. Okay. Chalo. Now listen, today I want to discuss, every day I am choosing one topic, myself also I want to update, because I am also getting some questions from the students of interview. Sir, I got this question. Sir, these concepts are asked in PS interview through GRADE. Yes, they may be asked or they may not be asked, Pramit Banerjee, but that I am expecting it may be, if you are thinking for only PSUs I can't say, but if you are going for the private sector, definitely they will ask you. Definitely, yeah. Why? Because the PSCs are also going for automation, right? Every PSC is under automation, right? They don't expect, you are already see, PSC interview means what, my dear? PSC interview means what? You already got selected in the gate score, good gate score, then only will call for the PSC interview, right? So then what is the use of asking again a question on basic of transducer, basic of op-amp? You are already ranker. So they will ask some fundamentals also. Okay. Yeah. So today's class, I want to talk about the communication protocols. The first one communication protocol is the HART, one of the advanced communication or one of the free software, free available communication, that is HART. So what is this HART? This HART is defined as highway addressable remote transducer. Highway addressable remote transducer. Highway addressable remote transducer. What is the logic to incorporate electrical machines in gate instrumentation syllabus? Very good question. As per my answer, they don't know advanced instrumentation topics. There are many advanced instrumentation topics like analytical instrumentation, lab view, PLCs, DCS, robotics. Instead of keeping that subject, they have kept the electrical machines. So either these 2 points I can say, either they could have not know about the vastness of the instrumentation, or they thought electrical students and electrical departments should override this instrumentation paper. That is only one answer from me, Anand Bose. Because when you go for the industry level, today advanced tools are coming, but the students are not having any scope to learn. At least even it, suppose if you have placed a PLC as a full length subject in the gate instrumentation, like some sensors and transducer subject is there, na? Like that he could have placed PLC subject or microcontroller as a full length subject at least. Microcontroller also they are not kept as a full length subject. At least the student will practice some programs. The student will practice some programs. But instead of taking that, they have removed the analytical instrumentation, they have removed the microcontrollers, they have removed the biomedical instrumentation, and they kept machines and EMT. What we can say, Anja Bose? This is how what's happening in our engineering college also. EC and electrical faculty panel will decide the instrumentation syllabus. Very rare engineering colleges like in Tamil Nadu, one of the beautiful colleges like Pondicherry Engineering College, PECUP, PTU, PU, these certain colleges are having good syllabus. But when you go for the Andhra Pradesh and Telangana, I observed many of instrumentation syllabus formation is done with electrical and EC departments. They will introduce their subjects like fuzzy logic networks, some advanced communication protocols they will keep, but very core advanced instrumentation like advanced instrumentation, real time embedded programming for instrumentation, sensors and intelligence, wireless sensor networks and IoT. So, these subjects they must be placed not only in this BTech level and also in the GATE level, then only the student can give a facility to know for the industrial gap. I was speaking correct, Anja Bose? Are you sensing Mr. Rohit Saini? Yeah. Today's lecture, just let us move for the highway addressable remote transducer. My dear students, you tell me how many of you know that in industry between the instrumentation field devices, from an instrumentation field device, if you want to get a data to the PLC or if you want to get a data to the DCS system, what is the standard protocol we are using? Tell me. In our basic instrumentation, if you want to send any signal, pressure signal or temperature signal, pressure signal or temperature signal or any signal, my dear, from a field device, if you want to send it to the PLC system, from a field device, if you want to send it to a computer, RS-232 is having certain limitation, right? RS-232 is a wired communication, right? Are you using RS-232 to transfer the temperature data? No. RS-232 is a digital data, right? It is serial data communication, bit by bit it will allow. But I want to take the temperature data, my dear. I am asking about temperature, pressure, flow. Fundamental question. See, this is what I am expecting. Yes. RS-484, no. My dear, they are all wireless. I am asking, they are all digital. I am asking the basic level. Instrumentation standard was there. There is one industrial standard. Wired, when two field devices, by using two wires, a field device is connected to a PLC and we are getting the information of level, minimum and maximum in the form of one loop. What is that loop? Current loop, my dear, that is what the 4 to 20 milliamperes current loop. Any signal, my dear, any signal is adjusted on this 4 to 20 milliamperes. In private companies, they won't ask you the gate score, my dear. So they will ask you the tool experience. They will ask you the experience on tools. Experience on tools. In private companies, you need. Yes, 4 to 20 milliamperes, very good, 4 to 20 milliamperes current loop they are using. Listen, my dear, today I want to talk about these points, 4 to 20 milliamperes current loop they are using. But what is the problem with this 4 to 20 milliampere? This is only analog, right? This is only analog. So, if you in an industry, the most fastest way of data transmission is for the digital. So, if I want to transfer or if I want to communicate between from the field devices to a master in a best way and in a sophisticated way, this 4 to 20 milliamperes is always related to current. That is why we have to use a open protocol which also enables a digital data transmission over a analog wire. So, that is what the HART. The HART introduced the superposition of the digital signal. The HART has introduced a new concept, superimposition of digital signal on the analog signal. To understand this, I want to tell one point. how the basic caller ID, how it works in our phone communication, basic caller ID in our telephonic communication. See, generally we are having a person here. So, this one person, there is a phone, okay, let us take there is a phone, and this is a phone, caller ID, let us take this is a phone, and here also one more person is there, this is a phone. Try to understand, they both are talking together without wire. What is the signal it is going? The voice signal is going or not? Yes, the voice signal is going. But have you observed on the same this voice signal, if you observe, there is a caller ID also. You are able to see the caller ID or not? Some number you are going to see or not? Are understanding? A caller ID that falls on your mobile or not? That means as long as you are talking, that caller ID is also displayable or not? Yes or no, my dear? So, how you are just imposing this caller ID and the voice signal together? Slowly in instrumentation they thought, why can't we introduce a digital signal over analog, and why can't we transfer it? So, that is the beginning of the HART. Are understanding Rohit Soni, Pramit Banerjee, Abhishek Pandey and Ananja Bose. Basic caller ID of telephone, how it works, just like along with the voice signal, I need a response, my dear. You know how difficult for a faculty to collect these topics. As an instrumentation students, you must know it, and you must also sense the efforts of the faculty in the coaching industries, like today's particular situation where the gate instrumentation is everywhere is facing a lot of issues. So, just like a voice signal and a caller ID superimposed, that technology they wanted to introduce into our instrumentation. Because if I am using 4 to 20 milliamperes, we know that is analog data communication or not was? Yes. Pressure signal or temperature signal, it is adjusted to 4 to 20 milliamperes. I am not here to explain the 4 to 20 milliamperes. Already in YouTube there is a 4 to 20 milliampere lectures, free lecture is available, you can go through. I have given that free lecture also, 4 to 20 milliamperes, free lecture is available on the YouTube. You can type 4 to 20 milliamperes current loop by Satish sir, Gate Academy. The temperature suppose is varying from 25 degrees Celsius to 200 degrees Celsius. By using a temperature transmitter, first of all it is converted to the voltage, and our transducer converts like thermocouple. Our thermocouple converts this 25 to 100 degrees Celsius, whatever the room temperature. For example, let us say this room temperature varying from 25 degrees Celsius to 60 degrees Celsius. This 25 to 60 degrees Celsius is converted to 25 millivolts to 60 millivolts or 0 or 10 volts, some voltage. By using a transmitter, this is converted to current signal first of all. Why only current signal? That also I explained to you. Transmitting a current signal is easy, transmitting a voltage signal is very, very difficult. Transmitting a current signal, yes, very good, V2I converter. Transmitting the voltage to the current transmitting current signal is easy over a long wired communication. If you are sending the signal in the form of voltage, as you know, V is equal to IR, each and every wire partition will have certain resistance that will create a voltage drop now, my dear. And by the time it goes to the end device like field sensor to that digital PLC system or analog module of the PLC system, then what happens? What is the voltage that you are going to get is very, very less. That is why we are using 4 to 20 milliamperes. Sir, why again 4 to 20 milliamperes? Why not 0 to 20 milliamperes? Everything I have explained. 4 milliamperes represent the liveness of your data. If it is 0 milliamperes means that represents there is a break in the current loop. You understand? That means if your temperature is 25 degrees Celsius to 100 degrees Celsius, for 25 degrees Celsius you should get 4 milliamperes. You are getting 0 milliamperes means there is a loop wire connection, disconnection ho gaya. All these things I have explained. Today's class is not about that 4 to 20 milliamperes. I want to talk about this HART. Many of the industries, many of the students have posed me a question. Sir, yesterday I went for Ferro Alloys company and yesterday I went for the National Instruments, Analog Instruments, Texas Instruments, some basic interview. They asked, I got for Yokogawa interview and they asked me, sir, advanced communication protocols like Modbus, Profibus, HART. Have you come across these words, my dear Bose and Pramit Banerjee? HART, Modbus, Profibus. Have you come across these words? BACnet, Ethernet. Have you come across these words? This is what the industry is expecting. Okay. Yeah. What kind of cable is used to transmit these current signals? Twisted pair, my dear, twisted. Why? The reason is what, my dear? Ananja Bose, why twisted? More is the area of cross section, the lesser will be the resistance. R is equal to rho L by A concept, basic simple concept. R is equal to rho L by A concept. The more is the area. If single wire, no, not single wire, two wires, you twist it. Then what happens? The area of cross section increases. When area of cross section increases, its resistance decreases, the current ability will be more, na? Yeah, that is a point, Rohit Soni. All important subjects will go to final year. All good subjects which are industry related subjects like LabVIEW, artificial intelligence, machine learning, computer networks, that was the robotics, automation, and this one virtual instrumentation, LabVIEW, and embedded systems, real-time embedded systems. I mean real-time embedded systems means advanced microcontrollers like one PIC microcontroller or RISC microcontroller or LPC214 microcontroller like RTOS concepts, taking multiple interrupts handling technology, multiple interrupts handling by a processor. We in our BTech, we even not completed the arithmetic logic operations, sir. Just we did the arithmetic addition, subtraction, multiplication, division over. But in industry, they're using the smart devices to handle the multiple interrupts without RTOS understanding that we cannot do. So all these technical basic subjects will go to the final year. Final year means everybody is busy, faculty is busy. So this is a point, my dear. So students should spend some. Students should invest some time. So as a friend I am telling, you must invest certain time. Today, how much time? A daily half an hour time is also enough better. Daily half an hour time, a smartphone you have, a internet connection you have, just on YouTube you go there and you type. I am also studying YouTube and collecting the data and preparing. Advanced communication protocols in instrumentation, advanced instrumentation tools. What is DCS? You type what is DCS, what is PLC, what is RTOS, what is watchdog timer. Have you typed it? What is LabVIEW? What is web publishing? What is the machine learning? Just half an hour. You can get some videos, prepare some content so that at least you should have some vocabulary to talk now when you go for interview. You should have basic vocabulary when you want to express. Now you are in a position to talk. Somebody asked me twisted pair. Very good question. Twisted pair or coaxial cable. He is having good knowledge. Sir, we are telling 4 to 20 milliamperes. That is an interview question. 4 to 20 milliamperes. Why current only? Why not voltage? Why 4? Why 20? And recent times, what is advancements of this 4 to 20 milliamperes? 4 to 20 milliamperes, they will ask in our Viva, BTech Viva. But when you come out of the BTech college and when you go for the industry, they are asking the advanced, that only I am taking today, HART, Highway Addressable Remote Transducer. There is an advancement of the 4 to 20 milliamperes. And after that, Modbus. There are many things, my dear. All of you understand? So next thing, after this, there is one company called Bell 202. I think that I exactly not remember. Bell 202. This company has added one topic. So keep this in mind. This is first point I want to express. Basic caller ID, how it works. Some people have some idea, right? So along with the voice signal on our telephonic wired communication, whatever we are using landline phone or mobile phone, whatever, caller ID and the voice signal, how both are synchronously going. This is the first idea where two signals can be done. In digital, Bell 202, this company has introduced one technique called Advanced Frequency Shift Keying Method, AFSK method. I think AFSK method, Frequency Shift Keying method. This AFSK method, what it will do? Any idea, my dear? AFSK method. One of the interesting points, this AFSK method. Any idea, anybody? Anybody? Like PSK, very good. What is the digital communication method, my dear, here? One second. Some voice point. Yeah. Yes, advanced frequency shift keying method means what? No idea. Remember, if I am having two different frequency signals, suppose if I am having two different frequency signals, see for example, मेरे पास एक 1200 Hz signal है. Listen, this is the 1200 Hz frequency signal. Listen carefully. This is a one signal like this. And another signal 2000 Hz, suppose let us take 2000 Hz. 2000 Hz, more frequency signal. Now, I want to send this signal, I want to choose these two signals to be transmitted with some technique, a digital technique. Okay. How it is possible? See, what I will do, I will use a technology to switch between these frequencies, a digital transmission technology. So, first whenever whenever it is connected to 1200 Hz, so this particular 1200 Hz signal in digital I will take it as some 0. Next, this 2000 Hz signal, this 2000 Hz signal is there now. When the switch shifts to this side, when the switch shifts to this side, this 2000 Hz signal I am taking, this 2000 Hz signal I am taking like this. So, this is taken as 1. Next, I am taking again the 1200 Hz and next again the 2000 Hz like this. So, in the format of digital bits, you understand my dear? all of you, my voice is clear? एक बार मुझे confirmation कर दीजिए बेटा. When say one second. When is our next class of instrumentation for the B.Tech students? Asking. Yeah, it's live. Yes, do you understand? Very good, Orange Boss. So, that is the way. So, this is what developed by whom? Bell 202 standard.
You understand? Very good, Orange Boss.
This is what we call as frequency shift keying based. So, this is what we call as Bell 202 standard actually. So, this technique is second. So, this is a second technique my dear. So, now in a what we call, by using this both the techniques, one is the telecaller ID, one is the telecaller that was telephone caller ID and this Bell 202 technique. These two techniques, by mixing these two, now we have introduced a protocol called HART, so that the remote field devices also can transfer the data. Multiple field devices also can be accessible by a control system or a PLC system or a DCS system by using a HART protocol. Do you understand, my dear? Getting some knowledge? Yeah. So, now I will go to the actual content. All of you got an idea? So, this was a history before the HART. How the HART was developed? HART is a open software, open free communication protocol to connect the field devices. All of you understanding, my dear? Any doubts you can ask me. So, it is globally accepted standard for sending and receiving the digital information. Sending and receiving the digital information across the analog wires. Very interesting topic. Across an analog, a caller ID, how it is going, we are sending the digital information on an analog wire between the smart devices and control devices like PLC and DCS systems. What are the field devices? I will show you. So, let me talk about this, about the HART protocol. The basic things, please note down, my dear. Please maintain a interview students, please maintain a notes. What is the HART protocol? The HART protocol, this is the information, content information. This HART protocol was developed in the mid 1980s. By who? The name of the company Rosemount Company, for use with a range of smart measuring instruments. At that time it was a beginning, but today in IoT it is a must. Now, what is happening in a car? When a person is entering into his apartment area itself, automatically his gates are opening. That is the IoT technology today we are using. By the time when the GPS system that a car is having the mobile, car inside the mobile is there, when the car is entering into the home itself, automatically every electricity, everything getting on. And when the person is going from out of his home, automatically all the devices are getting closed. This is what we call as smart home today. Smart homes came today. So that electricity bill is saved, water bill is saved, no watchman is required, no security is required, automatic alarms, automatic locked systems, automatic level control, automatic current control, automatic voltage, automatic power control, automatic light control. These all sensors and field devices are operated with a technology called IoT. So, there comes smartness, but it was begun in the 1980s, my dear. Are you getting my point? Yeah. Now, listen, field device, originally proprietary, the protocol was soon published for free. By the 1990, the HART user group was formed. That is one of the advantages. So, instrumentation students should know, is there any free software is present, free protocols are present? Yes, sir. Just like HTTP we are using in the www.https we are using on the websites, we are also using the HART instrumentation. And there is one communication foundation was formed in 1993. There is a HART communication foundation was formed. The protocol still remains open and free for all to use without royalties. So, you should know all these things, my dear, a free open protocol that is present. Next, just I will go through this content first. Let us see the introduction. You should know the basic understanding what is HART. HART stands for what? HART stands for Highway Addressable Remote Transducer. What is HART? If any industry people ask you, you should explain what is HART. It is a global standard, my dear. It is a global standard, just like RS-232 is a global standard for communication. Just like Bluetooth is a communication, Wi-Fi is a communication. Here also, it is a global standard for sending and receiving what? Is it visible or not for you? For sending and receiving digital information. Very good. Sending and receiving the digital information across the analog wires between the smart device and control, between the smart device and PLCs. What are the field devices? Field devices is nothing but our sensors and actuators. Sensors, DCS, actuator. Sensor, transducer, PLC DCS system and actuator. Sensors and actuators are field devices, my dear. What are the field devices? Pressure, flow, temperature, transmitters, valve positioners and actuators. These are the field devices. After this, digital networking facility to access any instrument, any field devices or any controller for configuration and diagnostics from any point of the network. That is a beautiful thing. If you use the 4 to 20 milliamperes, my dear, you have to make some configurations, some current wired connections properly. But here what you are doing, you are configuring the devices. That is what you can do by using our PLC also. When you are dumping the PLC program into the PLC logics, RS logics, and when you are opening the SCADA software, what is happening? You are configuring the RS logics, you are configuring the devices. And next, digital information utilizes the existing, see here, this is the last important point. The digital information utilizes the existing 4 to 20 milliamperes. It is not violating the 4 to 20 milliamperes, it uses the 4 to 20 milliamperes and makes it easy to deploy in new as well as existing systems. Do you understand, my dear? Are all of you getting my dear, my students? Yeah, it uses the 4 to 20 milliamperes and makes it easy to deploy. Yeah, as I told you, what is the history of this? Just before I told you, the caller ID is a history. See, generally it uses what? 1200 baud frequency, please make a note of it. It uses 1200 baud frequency shift keying based upon the Bell 202 standard to superimpose digital information on the 4 to 20 milliamperes analog signal. It is just analogous to caller ID. Provides flexibility which is not available with any other communication protocols. If you want to make any communication with any device, definitely you have to do some settings, but here it provides some much flexibility. Very good. A DAS system is placed before PLC, since PLC process digital data only, yes. Not only, see, Aranja Bose, PLC is also having analog module. PLC is also having analog module, we can connect the current signal or voltage signal to the analog module, but inside the analog module again analog to digital conversion will be there. PLC can be useful for connecting the analog data and digital data both. That is the advantage of PLC over the microcontroller, Bose. What is the advantage of PLC over microcontroller, microprocessor? Microprocessor they can take only in a limited level, they can take analog input also, like some of the microcontrollers like LPC2148. Some of the microcontrollers like PIC microcontrollers, they are having some inbuilt ADC, but they are not suitable for the robustness of the industry. In industry, suddenly the temperature changes, analog signal also changes suddenly, that much fluctuations and that much drastic robustness a microcontroller board like a Raspberry board or our basic boards may not sustain. That is why we are going for the PLCs. Why is this analog to digital conversion? Directly I will send the current signal or voltage signal, means PLC analog module available here. You got it? Yeah. Chalo. Is it clear? Have you understood or not? So now I want to show you how the HART works. If you see, this is the HART device. Have you observed? All of you are able to see this picture? So this is a 4 to 20 milliamperes current signal. On the 4 to 20 milliamperes current signal, we are sending the digital signal in the format of this. So these are different frequency signals. So this is what our 1200 Hz. This is one signal. And on this we are sending what, my dear? On this what we are sending here, this is another frequency signal. It's a 2000 Hz signal like this. So wherever this 1200 is taken, this 1200 is taken as in the form of 1 and this one is taken as 0, okay, like this. So this is the way how they are sending in the form of digits. This is 1, this is 1 and this is 0, like this. They are sending in the form of bits. Superimposition of digital signal over the analog 4 to 20 milliampere. This is why, what is this line? What is this line? This line is what we call as the straight line. This is the 4 to 20 milliamperes line, my dear. On the 4 to 20 milliamperes line, we are sending the digital data. So, how it happens? See here. HART is an acronym for Highway Addressable Remote Transducer. The HART protocol makes use of the Bell 202 frequency shift. Please make a note of this point. What is the technology inbuilt in the HART? That is called Bell 202 AFSK, Advanced Frequency Shift Keying, actually AFSK method. Please make a note. Are you maintaining the notes? AFSK, Advanced Frequency Shift Keying standard to superimpose the digital communication signals at a lower level on the top of the 4 to 20 milliamperes. This is one of the important thing, my dear. Now, how it is possible? See here, some information. If you observe this, it's two-way field communication is possible, because the data can be collected from the sensor to the PLC DCS system and the PLC DCS system to the sensor. Here, not only the data of the sensor, if you want to make some configuration to that sensor, that you can do from the master. That means you can take the sensor and the field device as a slave and the PLC DCS system as a master. See here, the HART protocol communicates at 1200 bps without interrupting the 4 to 20 milliampere signal and allows a host application, which is called master, to get 2 or more digital updates per second from a smart field device. The smart field device can be taken as a sensor. So, now one PLC system is there, I have multiple smart sensors are there. One PLC system is there, I have multiple sensors are there, but remember, these all sensors which I have connected, they must be having a configuration setting to support the HART. A HART enabled smart sensor can only communicate with a HART enabled controller. Are you understanding, my dear? A HART enabled smart sensors only can communicate with a HART enabled PLC or HART enabled DCS. Are you getting this point? Compulsory, the sensors must be configured through the HART. First they have to be configured to the HART, then only that particular sensor can communicate with our PLC DCS system. That is one important point you must understand. All the sensors must be HART sensors. Ante HART sensors means what? A sensor is already there. For that we are making some settings of just like when you are opening the software, settings we will do now. When I am starting this video lecture, I have started the stream software, I opened that, and in the settings I have kept the YouTube key. This particular lecture, there is a key, right? YouTube key will be there. So, the stream code key will be there. The stream code, if I type over there, then automatically what happens, it is a live class, I will be connected and you are enabled to see my lecture. Suppose in the place of that YouTube stream code, instead of my Satish sir content, suppose Umesh Dande sir's analog electronics topic is going on, he kept that analog electronics, then what happens in the morning 9 o'clock where I have to talk, but the stream code is taken the analog electronics stream code, then what happens, Umesh Dande sir class will be coming accessible to you. The same digital board and the same YouTube channel, in the same YouTube channel from 9 to 10 my class is there, but in the placement of the stream code, instead of my code, SAR code is kept, then SAR class is accessible to you. Do you understand, my dear? Do you understand? So, that means what? You are in a position to access another faculty as per the settings. That is the way how the HART enabled sensors can communicate with the HART enabled PLC DCS system. And one more important point, the frequency shift signal is a phase continuous, so there is no interference with the 4 to 20 milliampere signal. It is a phase continuous, there is no interference with the 4 to 20 milliampere signal. And most important, it uses the master slave, most successful protocol, master slave, which means that a smart field device only speaks when spoken to be a master. That means the master is having control of the slaves. It can activate a particular slave at a particular time, it can mask other. This is most important, this masking concept is most important. I think you could have studied this masking mechanism in the microprocessor interrupts, non-maskable, maskable interrupts. A master, whenever it is in a position to discuss with multiple clients like slaves, like sensors, it should have some priority to mask certain field devices for some time and only access to certain field devices, and once again this mask this and access that. This master slave protocol comes from the microprocessor subject, my dear. Yes. Do you understand? HART technology is a master slave protocol. Multiple slaves can be connected to the HART controller. The HART protocol can be used in various modes such as point to point. See, this is also important. It can be used as a point to point or multi-drop for communicating information to and from smart field devices. It can be point to point, it can be multi-drop also. I will show you the pictures. See here. Yeah, if you see this device, I think you are able to see this picture clearly. Clearly visible or not? Yeah. So, if you see before this, I want to show one point. The HART protocol provides two simultaneous communication channels. One is a 4 to 20 milliamperes, other one is a digital signal. The 4 to 20 milliampere signal communicates the primary measured value using the 4 to 20 milliampere current loop, the fastest and most reliable industry standard already there. Additional device information is communicated using a digital signal. That means I have a sensor, I have a field device. That field device is, let us take thermocouple. It is 4 to 20 milliamperes. By using the 4 to 20 milliamp concept, it has converted that into temperature to voltage. Now, there is another one, pressure transducer. By using 4 to 20 milliamperes, it converted 3 to 15 psi to 4 to 20 milliamperes. Do you understand? Are you getting my point, boards? Other one is a some level transducer, which is converted the 10 to 40 centimeters of the liquid level into 4 to 20 milliamperes. Now, I have a temperature signal, I have a pressure signal, I have a liquid level signal. This temperature signal is converted to voltage by using 4 to 20. This pressure signal is also converted by 4 to 20, and this current level signal also converted. But now, I have to configure for the temperature data which is coming from the 4 to 20 milliamperes, that particular temperature data, that particular 4 to 20 milliamperes signal is there now, that I will take it as 1 or some digital code. I will allot a digital code, to for the analog signal which is coming. That is what we call caller ID. I am giving a caller ID to the temperature signal. Are you understanding? It's a beautiful thing you must understand. I have the three field devices say 4 to 20 milliampere signal आ रहा है. एक particular signal को एक time मैं लेना चाहता हूँ. At a time I am accessing this, I will take the other two as MUP, and whenever I want to take this, other two as MUP, and when I want to take this, other two as MUPed. Are you understanding, my dear? Is it clear or not? That 4 to 20 milliampere signal communicates the primary measured value. Additional device information is communicated. What is additional device information? Additional device information is communicated using a digital signal that is superimposed on the analog signal. Very, very beautiful concept. Next, what is this digital signal? This is most important. What the digital signal information contains? The digital signal information contains from the device, including the device status. The device status, which a field, whether it is a thermocouple device status is 1 now. That means I am accessing the 4 to 20 milliamperes which is coming from the thermocouple, and I will keep the other field device status as 0. That means the pressure 4 to 20 milliamperes and the liquid level 4 to 20 milliampere signal is 0. That means I am not taking now. Device status and diagnostics, that means I can make it as accessibility master and slave. Additional measured or calculated values, these are the extra things. Okay, do you understand what I mean to Clay? No, not different ports, my dear. They are traveling on the same 4 to 20 milliampere signal, but I am configuring the sensors. By using the HART settings, I am configuring the sensors so that when I configured, automatically the data is going to coming from the temperature. That is what I am telling. On the same wire, we are not having multiple 4 to 20 milliamperes wires. We are having a single channel of 4 to 20 milliamperes. On the single channel of 4 to 20 milliamperes, we are mapping the different digital information. Got it? That's it. Yeah. See here. If you see here, this is a HART enabled IO device, this is an intelligent HART device, this is our sensor. See, I use the word as intelligent HART device, that means you should have some HART settings. It should be in a position to be configured by this particular controller. That's what is called intelligent HART device. So, now this is the data which is coming from this particular device, and I am using the 4 to 20 milliamperes, and there is a digital data, HART digital data is coming. HART digital data is coming. HART digital data means what? This device information, which particular device it is, what is its status, what is the diagnostics, what is the configuration settings for that, all that information. Just like when you are talking on the phone, along with the voice signal coming from your friend, you are also able to see his phone number. The digital code is of your friend's phone number. The digital code is of your phone's number. Do you understand? Whenever this phone is cut, some other your mother or father calls, are you going for some other area or some other channel? No. The same phone, the father code is coming and you are using the same voice signal. Do you understand, my dear students? Don't think that for father there is a separate wire line, for your friend separate wire line, for sister separate wire line. It's not like that. Your caller ID is showing, your same phone is able to show whenever a person calls to you, along with the voice signal, it is showing the caller ID. Yeah, that's how it works. Okay, see now, if you have two masters, this is one of the beautiful thing. I have two masters. One is my primary master like PC, personal computer, which is having certain software, and other one is a secondary master, temporary software like handheld smartphone. This is one master, this is one master. Try to understand, my dear. This is master number 1, this is master number 2, a smartphone. Now I am used to connect this particular HART field device by using the 4 to 20 milliamperes line. The same 4 to 20 milliamperes line is connected to two masters. First master is a primary master and the second master is a smartphone. Two masters are able to get the data from the field device. Are you understanding, my dear? Are you getting the clarity here? But here there is a HART modem, and this HART modem will configure these two terminals. Beautiful, right? This is how the instrumentation is expanded, Ananja Bose, in industry. Two masters. Yes. Next. See, the HART protocol provides for up to two masters. HART protocol provides up to two masters, primary and secondary, two masters, maximum two masters. This allows secondary masters such as handheld communicators to be used without interfering with the communications to and from the primary master. Do you understand? Are you getting? Without disturbing the primary master, they are able to communicate. Without disturbing the primary master, they are able to communicate. The HART protocol provides for up to two masters. This allows the secondary masters such as handheld communicators to be used without interfering with communications to and fro from the master, primary master. Chalo. Next. So, as I told you, there is a point to point mode. That means, see this picture, I want to show you this picture. This is point to point. So, this is a point to point, field device is there, master is there. This is a point to point. But whereas multi drop is also there, that also I want to show. Multi drop. Yeah, this is a multi drop. Two masters. Multi drop mode. Ante multi drop mode, what is the point here? I want to tell you. Multi drop means what? See here, multi drop. Are you able to see here? Boss, this is a multi drop. Previously, what I have explained is the field drop. I think all of you are able to see this picture clearly. Thoda sa images try to correct because the content I have collected from the web is the similarities. Is it clearly visible now? Yeah. Multi drop means, see, the different field devices, they are connected to the two masters, primary master and secondary master, on the same 4 to 20 milliamperes. Now, do you understand, boss? We don't have any separate lines on the same 4 to 20 milliamperes lines were accessible to this particular sensor, this particular sensor, this particular sensor, or not only sensors, actuators also. I am also saying actuators, not only the sensors, it is also for actuators. Yeah. So, that is a multi-drop mode. Okay. So, just go through this content, I have collected this content. So, I will, it is available in the net, you can type the HART, you can get lot of content. In multi-drop operation, the devices exchange their data and measured values only via the HART protocol. That is the point you have to understand. The analog current signal serves just to energize the two wire devices, providing a direct current. And what is the purpose of this particular current? Just to enable that particular line current loop. Remember, my dear, how many devices can be connected? Up to 15 field devices are connected in parallel to a single wire pair, and the host distinguishes the field devices by the preset address. That means how many devices? 15 field devices can be connected. The multi-drop mode of operation requires only a single pair of wires, and if applicable, safety barriers and auxiliary power supply up to field devices. Do you understand? Is enough. 15 field devices can be connected, my dear. That is the way. 15 field devices, up to 15 field devices can be accessible by using the two masters. 15 field devices, giving the number 1, 2, 3 like this, and this is a superior master 1 and this superior master 2 on the same 4220 milliamperes wire. And which particular data is coming, from which particular sensor the data is coming, that is configurable by the master. All of you understood? So, you got the good idea of some basic idea of this lecture HART. Okay. So, basic ideas must be there, not in-depth idea, because we are not working on the HART in our college. Maybe some of the PLCs, those who are having the PLCs in college labs, they may be using the HART communication protocol, but most of all the instrumentation, most of all the colleges, this HART is not properly present. That is why, but in industry, not one sensor, if you are taking a sugar manufacturing company, a bread manufacturing company, or a oil manufacturing, a paints manufacturing, any manufacturing company you take, many field devices, many sensors are to be connected to master. So, there a advanced communication protocol was introduced, that was a HART, and how HART works I have given the lecture today. Is it clear, my dear? So, please try to focus on the content. Okay. So, as I told you, these are the latest technologies, you should have some basic idea for interviews. Okay. Do not curse anyone, it is our fault, we have to learn and we have to go ahead. Okay. It is our thing. If you want to settle, you have to learn on your own. You have to go to this level of understanding of these things, we have to start learning. If you want to settle in the industrial field, private industrial field, no sir, only GATE means already GATE coaching already, that I am giving already content. Okay, the sensor subject, sensor transducer subject, optical, that is available for you, that is secondary, that is GATE. Okay. But what I am talking, if you are going for interviews, if you are going for industries interviews, definitely आपको ये mind में रहना है, basic understanding, at least some basic, daily half an hour you maintain a notes, that is enough. Yes or not? Just in a matter of half an hour, we have taken almost 45 minutes lesson. We got some idea, right? Like that, you also spend some daily half an hour, you see some YouTube videos, you see some industrial videos, many industrial websites, YouTube channels are present, Enter Session is present, PAS is present, Nation Instruments channel is present, many companies, Yokogawa is present, many companies YouTube channels are present, you can subscribe there and you can get the latest visual animation pictures of these things. The only thing is, this is what we call as literature review, what we call this as, in research we call it as literature review, we have to review, we have to study. If you are going for an interview is different from the GATE, my dear, you should have some basic review, and this interview process is a everyday process, not like that you have selected the GATE, then only after the interview, after the rank comes, then only I will go for the interview, within 2 days I will prepare everything. No, GATE is only till the exam, but interview is everyday process. Every day you have to update, every day half an hour you try to know some latest technology, or if you are in the college, you go to the PLC lab, you go to the LabVIEW lab, you go to the microcontrollers lab, or you go to the IoT lab, learn something, my dear. This is not the days that instrumentation means only this, EC means only that, EEE means only that. Now everything is integrated. The life of the industry is now integrated, my dear. You should have some basic idea. If you are in the college, please visit the labs, try to just watch the experiments, what is happening and how the configurations are done if you are in the college. In the college, if your labs are good, go to CSC labs, go to EC embedded lab, go to instrumentation PLC lab, go to IoT lab of CSIT and learn something, because the technologies which are coming now in industry like data science, artificial intelligence, big data, these all are going to integrate every field of engineering, my dear. Our sensors will collect a bunch of data. This bunch of data has to be analyzed by using some softwares called big data analytics and certain tools called machine learning, and they will make the decision. They will give you a proprietary data, information. The actual information of from the data, from the bunch of the data, they will give a single line of information, the average temperature, by collecting a bunch of data. So this mechanism is happening nowadays in industry. That is what the perfect automation direction. So people should have some basic idea of all these things also. So I hope all of you enjoyed my session. Love you all. We'll meet in the next session. Jai Hind.